what's up everyone? Frank Valkyria, yes, it's still me, the dude with the hoodie. I love this hoodie, it's one of my favorite. I really have to find one also of some other movies that I love. I recently watched like Back to the Future reunion on Zoom or whatever, like done by this actor. I forgot his name. That was super awesome thing. That was a super awesome video. I just love to see everybody on that Zoom call. Anyhow, today we're gonna do something different because we are reacting to the size. Relax, the size. You don't have to get naughty on me. Relax. Immediately thinking of other things. We are reacting to the size comparison of the universe. That's exactly right. So let's go together and let's get our mind blown. Boom. Boom. Always thinking of stuff, eh? Always thinking of stuff. Go check out the original video here as well. It's linked below. I have no idea what you're talking about. Planck particle, it's something extremely small. 1/15 times 10 to the minus power of 34. I'm an ignorant. Wow. That's already incredibly bigger than the thing before. More or less, just... Wow. What? Hydrogen atom. Wow. What? Oh man, already in the small, there is so much distance in between small and small that I already don't understand nothing. Absolutely have no idea. But I feel so much. If I see like, you know, to the time, minus 10 or whatever it's pronounced, 10 or 20 or 15, it feels like, you know, the magnitude is so big, so much bigger. Wow, look at the difference between like that and a DNA. Wow. What the heck is this thing? Bacteriophage. Looks like... What a design. Wow. Looks like the blood cell looks like a little comet or something. Paper thickness, wow. Computer monitor. All right. Let's see what's going on here. Computer monitor. That's pretty awesome. Hey, that's what's the program? Human. Okay, we will go this far. Argentinosaurus, 35 meter. I thought that the heavier creature ever to live on our planet was, or is, a blue whale. Probably it is in terms of mass. Wow. Actually, I'm still blown away by the fact that there's a building that is almost a kilometer high. Comets are pretty big. You really don't want them to smash into Earth. Wait, what? Wait, what? Where is wait, what? Sedna? I have no idea Sedna were the UK, just to have a reference. Oh wow, the UK, 1,000 kilometers. Then this is pretty big place, even if it looks really small. Mercury. Too close to the sun. Already pretty big. Look how many UK you could fit here. Like, it would be like, if this was a planet, it would still be like, if it had a little bit of ocean, it would still be quite a big place, actually. Titan. Is it Titan a moon of Saturn or Jupiter? I always forget. Mars. Mars is pretty big. It's like more or less half of Earth. And then you realize how much water surface is on Earth. So if you have a planet that has less water surface but more land, you probably have you could have potentially, like on Mars, basically probably have the same space or more capacity of walking, because there is no water. Unbelievable. Those old spheres just floating into the freaking universe. Unbelievable. And Venus is very volcanic, and it seems like I don't know if I remember correctly, it's a sort of like sister Earth, whether it's in development or past the point of maybe when it was like Earth. Yeah, that's a mystery. I don't remember if I read that it's like maybe could have been like Earth, or it's developing into Earth. Who knows? Or maybe it's still too close to the sun. Already it's just unbelievable. Like when you realize that already in our solar system there is another planet. Look at this. It's like four time the size. I mean, just gigantic already, and it's already right here. And then when you see, like, look at that, Uranus or Uranus, of course, like everybody likes to joke, Saturn. Impressive. Just impressive. Just incredibly impressive. It's like 10 times the size. Wow. Little sun, Jupiter, and Mud, giant. Man, I want to live on a planet like Jupiter. Sun. Wow, look at that. It's like the sun. Where is it? Like this is Earth. Look how tiny Earth is next to the sun. Just incredible. And it's like so far away also from here. Altair. Wow, when we start to do this with stars, I just lose it. I just lose it because I'm like, come on. This is our sun. This is already like almost 3 times bigger. And then this thing, what is this? What is this? How can it be this large? And then it's not finished. Oh my God, look at this. 50 million kilometers. Wow, the North Star. Oh, good mother of heaven. The size, it just means nothing. It just means nothing. Look at this sun. And I know that in between there are many more which are either bigger. I don't know if this is the biggest one we know of, or in between there are anyway more to make the comparison. But you just realize you go from this, right, which is freaking gigantic. Oh, good mother of God. You go from this that it's just unbelievable, and then you go to this other thing that it's like, what are we talking about? What are we talking about here? Does it even fit in our solar system, this thing? Is it a black hole? Ton 618. Was it a black hole? Oort cloud. 1.6 light years across. Go figure what it contains. Messier 71. It is all names we give in the observable universe. The distance from the Sun to Alpha Centauri is 4.4 light years, and this is 26 light years across. My God, like the light has to travel for 26 years. I'm getting lost. I'm getting lost. Milky Way, 100,000 light years across. Do you realize that, you know, like why communication is so difficult? Let's say that there is like life, civilization on this other part or anywhere, like in between, like, I don't know, it's like 200 light years, you know, like very close. And you know, like radio frequencies or whatever, things that travel at the speed of light, it will take 200 years to get there. And 200 years to get back if you get an answer. That's why it's so complicated to receive any info about, you know, maybe there is stuff coming our way. You know what I mean? Maybe somebody already picked up the signal somewhere else. But this is only in our galaxy. I mean, there might be like so many planets like Earth everywhere here. We're trying to communicate, we're sending signals out or whatever, and if they've been picked up, somebody, you know, somewhere very close still, it still will take perhaps years, you know? I mean, you gotta be lucky that there is something close to our planet, let's say in the 50, 20, 15 years, light years away, and we could get like a response like in 30 or 60 and so on years. That's just crazy. I mean, how can you ever, if there's a lot of civilization on the other side of the Milky Way, you know, like 100,000 light years away, you know, it's gonna take freaking forever. And then you just realize Harry Hivet, 5 million light years across. I just don't understand anymore. And that's just one galaxy. I don't know if this thing includes like clusters of galaxies. Wow, 2 billion light years. KBC boy. It just goes nuts. What is this? Observable universe. 93 billion light years. Universe, you're crazy. And this is probably not even what you know. Still, we are theorizing here. The universe is infinite. It just makes no sense, you know, like it just makes no sense for our little brain. We really have to exercise and evolve to grasp. We don't even know if this extends beyond what we can observe, of course. Most likely, it's the case. And could it be there another 93 billion light years, or 10 times this, or 1,000 times this, or 1 billion times this? Infinite, that's what it would suggest, right? So it's crazy. Or maybe this is just part of so many, you know, like contained, whatever it is, sphere of multi-universes. It's just like, I already lost it when we saw the biggest star here in this video, and then you realize that the galaxy is just an immense place full of stars and full of potential planets, and it's just one of so many, probably billions of galaxies, you know, billions of galaxies. And then you realize how just we are incapable of leaving this place, you know, at least not very far. Like what it will take for us to understand distance and traveling into the universe. Is it even possible, you know, to travel in a linear way, so to speak, the way we imagine traveling on here? You take the car, you go from A to B, And obviously the distance from A to B, from here to the other branch of the Milky Way, it's like 100,000 light years across. And it's just, I mean, even if you had the technology, how can you do that? You know, like, we should find probably ways, if it's possible, to travel faster than light, or if it's really possible to sort of bend the universe, sort of drilling sort of holes into the fabric of the universe, with this idea, theory of wormholes. Even though, from what I read, wormholes are events which they are extremely small, so they would suggest that probably it's not possible for larger things to pass through, or whatever. Anyway, I'm just speculating on the little things that I read, because I love reading this stuff, and it's just always blows my mind. I mean, come on, guys. Sometimes when I feel like what we're going through and our petty problems, and the way we still hear bickering about countries and languages and ethnicities and religions and all that kind of mumbo jumbo, I'm thinking, like, this kind of stuff should be mandatory for every human being to ponder and wonder and discuss at a very early age, because it's the type of stuff that opens up awareness. And it just truly, and I mean, you're just in this biosphere, in this biosphere, protected by a thin layer of atmosphere that allow us to prosper and exist and think, and we're just moving on a freaking ball or whatever, you know, semi-bowl, semi-spherical bowl. And it's just this tiny part of this thing out there, which is crazy, completely nuts. Anyway, let me know, guys, if you want to see more video like this. It's nice to you know, to keep it varied, to keep it strange, and always spread love. Stay healthy. I'll see you later. Ciao.